today let's study a problem, and this problem is a1, a2 to an not or zero constant. And r1, r2 to rn is real number. And we have this inequality is r1 times bracket x1 minus a1 bracket plus r2 times bracket x2 minus a2 bracket plus point plus 2 rn times bracket xn minus an bracket. And this is less or equal to square root x1 squared plus x2 squared plus point plus 2 xn squared. And then minus square root a1 squared plus a2 squared plus point plus 2 an squared is satisfied for any real number x1, x2 to xn. And then we need to find the values of r1, r2 to rn, and actually these roots of r1 to rn is a set of roots because we can think a1, a2 to an is a constant. So from this condition we can find out you can a set of roots of r1, r2 to rn. So if we have this, so now let's solve this problem. So first, let's see. The first step is let's say xi. Of course, the I means I belongs to 1 to n. 1, 2, 3, 4 to n. Okay, so xi is equal to xi is equal to 0. Xi is equal to 0. So let's plug in this inequality. So we have, or I can say that tells us. Let's see here, and that's negative bracket r. Let's write it to sigma. Let's see, negative sigma I equals 1 to n, and then ri ai, and that's less or equal to negative square root sigma I equals 1 to n, and then what? And this says ai squared. So we have this in both times negative. So the less or equal to need to be opposite. So it will change to greater or equal to. So we have, that tells us sigma I equals 1 to n, and ri ai, and then that's greater or equal to square root sigma I equals 1 to n, and then ai squared. So let's see this problem too. Okay, so we got this inequality, and let's see if xi is equal to 2 ai. So we have, that tells us what? Let me see here. We have, of course, we just plug in this inequality. Same. So we have sigma I equals 1 to n, and then ri ai, and then that's less or equal to what? Let's see here. First, we say here xi is equal to 2ai. So x1 squared is equal to 4a1 squared, 4 times a1 squared plus 4 times a2 squared plus plus 2, 4 times a n squared. So we can factor out 4 in the square root. So we have in the square root, right? I just say the whole part, okay? Not the part in the square root, not the thing in the square root. Okay, so the whole part, including the square root, I can say that's square root, and then 4 times bracket a1 squared plus a2 squared plus plus 2an squared. So and then we can take out a 4 from the square root, so it will turn to 2. So 2 times square root a1 squared plus a2 squared plus 0.1 plus 2 an squared. So then minus 1 minus this part, so what we got, that is right. So we can just do sigma, so we can do sigma 1 square root sigma I equals 1 to n. So that is ai and ai squared. So if we have this, so let's look at this one and this one. These two inequalities. So what we have now, let's see here. First, let's see what will happen here. And the left side and the right side. The left side is the same right here, the left side, and the right side is the same right here, the right side. So we have now, and only different is in the middle of the inequality. I mean, this is the last one equal to, and this is greater or equal to. So they need to happen in the same time, so that only could be equal to. So that tells us, or you can say we have. Sigma I equals 1 to n, and then r. Let's see here. Ri, ai, and then that's equal to square root sigma I equals 1, and then to n, and then ai squared. So what do you have next? Let's see here. So now right here, now we can create a Cauchy-Schwarz inequality in the n dimension. So what's that? That is sigma I equals 1 to n, and then ri squared, and then times sigma I equals 1, and then ai squared. So what do you have next? Sorry, not next. Just let's keep on. That's greater or equal to bracket sigma I equals 1, and that's it. That's ri ai bracket squared. So we have, why is that? Let's see. Because we know this part of what's right here. Let's see. And first from this one, we can say both sides square. Let's see. We both sides square it, and what do we have? We have bracket sigma I equals 1, and then n, and then ri, and then ai bracket squared, and that's equal to what? That's equal to sigma I equals 1, and then n, and then ai squared. Okay, so we have this right here. Let's see. So this part is equal to this part. So well, let's see. So and this part need to be greater or equal to this part. So this part must be equal to 1 or greater than 1. That's right. So that means we have sigma I equals 1 to n, and then ri to the 2, ri squared, and that's greater or equal to 1. So let's and now the next step is, let's see here. So now let's say xi is equal to ri. So what we have is we're just plugging the inequality on the question. So we have sigma I equals 1 to n, and let's see here. to the 2, and then the minus sigma I equals 1 n, and then ri ai, and that's less or equal to square root sigma I don't read that. You know that, okay? Okay. And the next step is so let's see here because we have here. We have the thing right here, so and here you see so these two guys are the same, so they can be canceled out. And so we have, let's say we have, or you can say, that tells us, so sigma I equals 1 to n, so ri, and then ri squared, and that's less or equal to its square root. So what we have, its square root. This guy is less or equal to this guy itself, the square root of itself. So what that means, this guy must be less or equal to 1. That's it. We have sigma I equals 1 to n, and then ri squared, and then let's see it. This less or equal to 1. So let's look at this one and this one. So what we have sigma same. They need to happen at the same times, and the left part are the same and the right part are the same. So what we have is, let's see here. So and here only the difference of them only is this is less or equal to, and this is this is greater or equal to, and this is less or equal to. So they need to happen at the same time, so it only can be equal. So then ri squared, and that's equal to 1, right? So if that's equal to 1, and in the Cauchy-Schwarz inequality, what we have here? In the Cauchy-Schwarz inequality, because let's see here, this part equal this part, and this one choose 1, so the left part and the right part and the both sides are equal. So that means, and of course in the Cauchy-Schwarz inequality, we have Cauchy-Schwarz inequality, if the both sides are equal, that only can be satisfying A1 over R1 equals A2 over R2 equals point equal to AN over RN. So let's think. We just opposite the both sides, okay? Opposite the nth side. We just opposite every side. Opposite in every equals. Right here, we just opposite here and opposite. So we have it. So we have, that tells us R1 over A1. You know why, I just changed it back. Equals R2 over A2 equals point equal to Rn over An. Okay, so we have, let's write here. Okay, so first, let's see. Now we have two conditions. So we have this one. And then another one is over it. Let's look at these two guys. So what do you have now? You see, this is the condition of the answers. Okay, so first let's see, we turn from this function. First right here, each term, you can imagine that's Ri. times AI. And Ri times AI, we can change it to Ri over AI times AI squared. You don't know why I just do that. Let's see here. So we have, and we can factor because we know here, so we can factor Ri over AI out. We can factor out Ri over AI because they are all of them are the same. So we have brackets Ri over AI and then times sigma I equals 1 to n and then AI squared, bracket squared, and that's equal to, and the right part is no change. So we have, next step is times the 2n and both sides divide sigma I equals 1 to n AI squared. And so we have Ri squared over AI squared. And then and then times sigma I equals 1 to n and then 1. And then AI squared and then that's equal to 1. So we just divide this part right here and then both sides divide sigma I equals 1 to n AI squared, and then both sides times AI squared, and then both sides square rooted. So we have Ri is equal to
Positive or negative?
upside, and then we can say the square root of the whole thing is equal to, you can just say the square root of the numerator over the square root of the denominator. So we have, and that's AI, and over square root, and here actually is the sigma. Sigma this part is this part, and now we just expand that. So that's A1 squared plus A2 squared. A2 squared plus point plus 2 AN squared. Okay, so we have solved this problem. So just like original from the problem that I stated before, you see after this problem right here, actually you can say this is the set of roots of R1, R2 to Rn. You can say that's a set of roots of Ri. That's fine. So we have to solve this problem.